Hey all, welcome to my video. This is basically continuation of elevator design, right? So previously I have given you homework to introduce the strategy pattern and also simulate the elevator with the handle internal request also, right? See, this is the continuation of previous video. I'll strongly recommend you guys please watch the elevator machine coding round, the complete code, and then only come to this video, because there I have almost coded the 75 to 80% of code. Here I'm just coding only 10 to 15%, like. So I'll put the link in description. So please go and watch. Then come here. It become very easy your life, right? So yeah, let's go to the system. Let's have a package. STRATEGY. So this is a strategy. Let's create a interface, right? Which will called let's call the elevator assignment strategy, right? STRATEGY, right? So we have basically have the elevator assignment strategy, in which so what exactly it has basically written the elevator, right? Assign elevator. So this is exactly we might need to has the overridden method. Okay. Right. So here let's go to here. Yeah, right. I think public we don't need to explicitly call, and this is also interface. I don't know why it was not reflected, right? Okay, we got this one. Now let's implement this one, this scheduler only. Let's give the better name, right? Let's rename this one to the let's what we can rename, like nearest elevator STRATEGY, nearest elevator strategy. Cool. Here we can basically do the implements elevator assignment strategy, right? Nothing is basically changing. Everything basically as it is, right? We didn't change anything, right? Cool. So now I think this will work fine. Now we need to slightly change our elevator system controller. Now instead of having instead of having this class, let's have the elevator assignment strategy. Let's have the assignment strategy here. Let's have assignment strategy. Assignment strategy and assignment strategy. Assignment strategy. Cool. I think we are pretty done, right? So from here, yeah, already there. We don't need to do anything, right? From here, I can basically now test out like multiple strategies. One could be nearest elevator strategy, and second thing could be a different strategy, right? So here instead of hard coding like scheduler, I can do assignment strategy, right? Cool, right? Nothing needs to be done. Everything works as expected, right? So now if you just run, I think you shouldn't get any issue. Like everything basically works as expected only. Right? Okay, everything starting at the same elevator. Now ideal closed. Got it. Right. So now let's do the small changes here, right? So instead of starting everything at the ground floor, let's start everything at the different locations. So for this, I can do something at the driver method, right? For now, let's have let's take some random values. Okay, let's have I can have 3 elevators, and these are basically any random values. So okay, I'm using the nearest elevation strategy. So controller dot get elevators. Okay, get elevators are not there. We just need to implement that one so that I can basically simulate I can just have the getter generator. Yeah, right. So I have get elevators dot get of 0 first elevator. Let's add the internal let's add internally, like someone internally from the elevator 0 wants to go to the ground floor. Okay, so controller, let's move, like let's move get elevators dot get of 0 dot move, right? So now this first elevator basically presented at the 0th location, at the ground floor. Similarly, let's do for other elevators also. We took 3, right? This is not a very better strategy. We can wrap this one inside a method and do this one. But for simulation purpose, it is fine. Like, yeah. So this one basically starts at 2, right? This is basically let's say it might be starting. Okay, it wants to go to the floor 3, right? And let it start at the 3rd floor. Okay, and this one let it start at 6th floor. Okay, so here the problem is basically we need to write the while loop so that it will basically quickly we can run the move method 3 times. It will go and sit at the 3rd floor. This is the simplest and easy way to simulate, right? Get of 1, get current floor is if it is less than 3. So in this case we can just simply do the move method, right? So similarly we can just do the same logic for here also. Get of 2 and get of 2 less than 6, right? So now if you see strategically, we have basically make sure 3 elevators are there. One elevator basically present at the 0th floor, one elevator present at 3rd floor, one elevator present at 6th floor, right? So now, so one thing we should make sure basically while moving all the elevators basically in the move state, right? Nothing will be in ideal state. We need to reset everything to the ideal state so that it's a perfect way. Now, whenever outside someone is basically requesting, we can apply the algorithm to assign these elevators based on the request. Now controller, let's reset here. Controller get elevators dot. So here how can we reset, right? So either we need to forcefully set the direction to the ideal, right? So now to do that one, go to the elevator class. Here you can simply have a method, right? Something like for example public void reset to ideal. So this dot let's say internal request, right? Internal requests are basically empty. We shouldn't make sure that there is no internal request are there because all the elevators are basically just starting from there. There don't be any other people or any other requests are going on. So door state is always basically closed, always closed. And we have this dot direction which is ideal. Right? So now in the elevators we can simply do the reset to ideal. Cool. I think now everything basically resets to ideal. Okay. So I think we have updated, right, the controller.getElevators and we have reset the to ideal. So now there are basically, if you try to simulate, so in the accelerator row, like, so for example, so this is the floor, this is the building, right? So one elevator is at basically 6th floor, and one elevator basically at the 3rd floor, and one elevator is basically at the ground floor, right? Now all the elevators are basically at the ideal state. So now the important part is basically how we simulate, right? So I'll explain the how to do the strategy pattern of two different strategies. We can refactor this one and also create a new strategy, maybe direction based strategy. We'll discuss a little bit after the. We'll discuss in a minute. But let's complete the this one, the driver method. So in the main method, so for example, let's say okay. Now let's update, right? Okay, from floor 2 it has to go direction 2, and from floor 4 I'm just simulating because from 0 it can go to 2, right? From 3 it can go to 4, and from 6 it can go to 7, just to make sure from 5 it can go to 6, right? Just to make sure whether things are working fine or not. As I'm setting at 0 3 6, so I'm also making like 2 4 5. So at the 7 maybe it will go to down. So now if you just simulate this one, if you just run this one, let's see how things will work. Then based on that we can basically maybe introduce a new strategy, maybe depending on the nearest elevator strategy. So see, all three elevators are basically 0th elevator basically at the floor 0, first elevator at the floor 3, and second elevator at the floor 6, right? Now we are assigning the elevator 1. We are assigning the elevator 1 to request outside basically of floor 2, right? So if you see elevator 1, which is at 3, right? Now someone basically wants to go to the second floor. We assigned the elevator 1, which is wrong, right? Actually, because of nearest strategy, which is thinking that ideally the best way is to not to we should assign to the elevator 0, but we assign to the elevator 1, I guess, right? But elevator 1 is already at 3rd floor, right? Which is going up, so it has to go to the top 10th floor and then come. So here this nearest strategy might not be working well, right? Similarly here. So here elevator 0 request out, we assign the 5th one to go to up, right? And elevator 2 we assign to the 4th floor, which is basically at the 6th one. Because of the nearest strategy at the absolute distance, this was basically a little bit messing up. So let's see how can we apply the new strategy. For now, let's copying the same strategy. Let's call it as a basically direction based strategy. Right, so direction based strategy. So how this direction based strategy works, right? So now this math dot absolute is not required, so let's remove everything. Right, so just simply what we can do, if elevator dot get direction equals to requested direction, if this is a true, now then we can simply let's take the current floor, right? Let's take the current floor. If elevator dot get current floor, right? So we have the so now we are going in the same direction and we are basically getting the floor. Now let's say now here request, let's remove this one also. So here what we can do, so here there are two things we can do. One is basically if direction is going up, right? If direction, let's say if direction is basically going up, if requested direction is going up and the current floor current floor is less than current floor, for example, which is basically 2 I want, this is basically 3, right? If current floor which is basically less than the requested floor, I can basically assign this one, right? Or else I can basically, while checking the down, if current floor is basically greater than requested floor, I can assign the I can basically assign that elevator, right? So similar strategies, this is a simple strategy I'm applying. So if request direction equals to direction dot up and if a current floor which is basically less than or equals to requested floor, or request direction equals to direction dot down, and current floor which is basically greater than or equals to requested dot get floor. In these two conditions, I am simply returning the elevator only, right? Simply returning the elevator. Here now minimum distance is not required. So this concept is also not required. So if elevator, if it by chance if it is not going in this direction, we'll assign the a random elevator which is basically the ideal, right? Otherwise we simply return the null, right? This is one logic, or else simply return the base elevator only. That has already a null, right? Cool. I think this should work. Now let's update this one. I don't need to change anything. Just go to the main method and just update the driver method, right? Like this one, direction based strategy. Now let's try to run this one. Let's see how the input changes. Here I'm applying the strategy testing. Now the nearest is basically not working. I'm going to direction, right? So this is also everything starting at 0th only. Now if you clearly observe, elevator 0 basically assigned for the request floor 2. Elevator 0 only assigned for the floor 4. Elevator 0 only assigned to the floor 5, right? Ideally here elevator 1 can be assigned, right? For the I think for the floor 5, elevator 0 instead of elevator 0, elevator 1 could be assigned, right? That is basically nearest one. But here instead of nearest one, we are taking the direction based, right? So people wants to go up. So so if you think, right, basically if you think, right, so here which is basically wants to go up, elevator 0 which is at here, right? And elevator 0, elevator 3 and elevator 6. A request came at a floor 2, right? At a floor 2 someone wants to go up, right? It is basically coming from here. That is basically correct one only, right? So that is basically already in the transit. Already it's basically moving, right? That's why for the elevator 0 only, for the fourth floor also we assign the elevator 0 only. But it could be assigned 3. For the 5th floor also it could be assigned 1, elevator 1, these two. We assign the elevator 0 because that has the same direction. Because we have basically taken the direction based strategy, right? Not the nearest based strategy. So in the nearest based strategy, that is a different algorithm, right? So if it basically elevator is basically 7th, which wants to go down, right? Which is basically randomly which is basically not in the same direction. So in the 3 elevators, 1 elevator is basically up and 2 elevators is basically ideal. In the among rest of 2 ideal, we randomly assign the 1 elevator, right? So this is how we got the 2, 4, 5 request, and then 4, 5 as it opened the door, and then again 4, 5, 5 it opened here. Similarly, rest all basically ideal and closed, right? So you can apply the even more basically better strategy maybe rather than along with these two. So it is like in the real interview. So this is the what people interviewer expects, not the what best algorithm you have used. It's up to you what best algorithm you will use, but we can also apply. Okay, this is how we can plug and play the multiple algorithms by using strategy pattern. This is the what somewhat they will expect in the real interview. So how you define the classes, how you basically dynamically changing the different algorithm, right? And how you basically simulate here, right? So you're adding the internal request, you're basically updating and resetting the ideal, right? So all things are basically happening in the real time, right? You are simulated successfully. So this is the overall elevator system designing. I hope you guys liked my video. Like I think you got something from this video, like regarding the elevator system. Yeah. So if you want to teach in different way, just feel free to comment in the comment section. Or if you like the video, so please do subscribe. In the next video, we'll come up with another machine coding round, which is even more interesting than elevator. We'll soon meet in the next video. So till then, like, yeah, bye bye. Hey, I'm recently on the bonding. I'm taking the one-on-one sessions, and also I have other courses as well and packages also. So for the and bonding basically offering the best features for the students also. For example, if you want to take the one-on-one mentorship, but if you don't want to pay the like 600 rupees, right, for 45 minutes session, or if you don't have that much money, basically bonding has a feature for the students exclusively. If you are a student, you can basically verify your email ID. Like while booking my session, for example, you want to book my session, let's say for tomorrow, let's say you can click on continue, right? You can just verify your student email ID. Once they verify, automatically 25% will be applied, right? So this is the one of the good feature provided by the bonding, which I am currently utilizing. So if anyone wants to have a one-on-one session with me, or students who cannot afford the big prices, for example, this is a quick chat. It is basically 500 rupees, but due to this bonding has a good feature, which I'm basically providing for the 50% off for the students, right? And people who wants to take the interviews with me, like, right, you can always reach out to me. You can basically follow to get my latest updates on any services or any courses.